The objectives of this example are to study 16-bit addition, consider signed and unsigned numbers, and evaluate the problems that occur due to overflow after an addition. Let's begin. The goal is to write assembly code to calculate N+1000 and store the result in a variable m. In this example, m and n are 16-bit variables. If we define the variables with a short in C, these will become signed 16-bit variables. However, if we add the unsigned specification to the definition of m and n, then m and n are 16-bit unsigned variables. The assembly language solution will be a three-step process. We'll first bring the value n into a register, we'll perform the addition, and thirdly, we'll store the result back into a variable. In this case, we've selected register D to operate because register D is 16 bits and it matches the size of the variable n, which is 16 bits. The execution of the load D instruction will bring the 16-bit value in memory location n into register D. The add D instruction will add, because of the pound here, add the constant 1000 to register D. So register D will contain the value n plus 1000 after the add instruction. Again, we've selected register D because it's 16 bits and we're doing a 16-bit operation. And the last step is to store the result into the memory location m. We are done. M is now equal to n plus 1000. However, a problem might occur because if we have a 16-bit number added to another 16-bit number, the result is a 17-bit sum, and we have stored the result back into a 16-bit variable, so an error or an overflow might have occurred. For example, if m and n were unsigned, that means they exist from 0 to 65,535, and the carry bit will be set after the add instruction if the result is wrong, or in particular, if n plus 1000 is bigger than 65,535. If we wanted to, we could test for this overflow condition using the branch if carry set instruction after the add. Notice assembly language allows us to look and see if an error has occurred. However, when we add in C, no particular mechanism is available for us to look at the carry bit. Conversely, if m and n were signed, and again in C we would specify signed using the short definition. If m and n were signed, then they would exist from minus 32,768 to plus 32,767, and the V bit would be set on an error if the result is incorrect. In particular, if n plus 1000 were less than negative 32,768, or n plus 1000 were greater than 32,767. And if we wanted to, we could test the V bit after an add and branch to an error condition if the result that we got was incorrect. Next, let's consider the difference between a 16-bit and an 8-bit operation. In this example, we knew n and m were 16 bits, but in the last example, m and n were 8 bits. Because m and n were 16 bits, we used 16-bit register and a 16-bit addition. And we had a problem when 16 plus 16 gave us an overflow into the 17th bit. Conversely, if m and n happen to be 8 bits, notice in C there's very little difference between these two lines of C code. But if m and n were 8 bits, we would have used an 8-bit register, an 8-bit addition, and had the problem of overflow because an 8-bit plus an 8-bit gives us a 9-bit sum. Next, let's review the difference between unsigned and signed operations. In C, we had to specify the variables as unsigned using the unsigned designation. The short specified these as 16-bit variables, and this one is a signed 16-bit variable, In this example, they're unsigned 16-bit variables. But in C, the operation n plus 1000 equals m is identical, whether it's unsigned or signed. However, in assembly language, we do have to consider whether the number is signed or unsigned. And we see that we would test the carry bit and branch if the carry bit is set on an unsigned overflow, an unsigned error. Conversely, we will check the V bit after a signed overflow. So, we have to know in advance, as an assembly language programmer, whether the number is unsigned or signed, and use the carry bit if it's unsigned, and use the V bit if it's signed. So, in summary, we looked at the 16-bit addition using the D register. We considered the difference between signed and unsigned numbers during the design of the system, and an overflow which occurs after an addition because the number is bigger than 16 bits. Thank you very much.